Welcome back. In this video, we're going to be looking at this nice, beautiful little series here, and we are asked what is occurring for the overall sum when we start at 4 to infinity. What is the sum of that series? Pretty interesting little question here. How do we go about it? Well, I want you to recognize one thing. When we have a constant over a quadratic or any other term, polynomial, we can split it up into what's called partial fractions. And how we do that is we take the denominator, we split off every irreducible factor, and then we're going to put those factors over something. All right, so let's get into it. So we're going to actually, we're going to find that this is going to turn out to be a, what's it called, a telescopic series. So how this turns out is, okay, we have 10 over n squared minus 4n plus 3. This is equal to, and let's factor the bottom, two terms multiplied by each other. We're going to find out this is minus 3 minus 1. n minus 1, n minus 3. Do the math, FOIL it back in, you'll get the same exact thing. Now what we can do, these are irreducible factors, meaning they can't be simplified anymore. What we can do is we can say, okay, well this is equal to a over n minus 1 plus b over n minus 3. We are allowed to do this because for every linear irreducible factor, we put a constant. If this was a quadratic factor, then we'd have to put ax plus b for if it was for the first one there. But knowing this and knowing that this is equivalent, we can now solve for a and b respectively. And how do we do that? Well, take a look at what each has, and I'm going to continue down here. If we want to make just the numerators equal so we can solve for a and b with, systems of equations, what we can do is we can say, okay, n minus 1, well, all that's missing in the denominator is n minus 3. So what we're going to do is we're going to say a times n minus 3 over n minus 1 n minus 3. So we just multiply top and bottom n minus 3. We're going to do the same with b, but with the factor it's missing, which is n minus 1. So this is n minus 1 over n minus 1 n minus 3. If this is equal to this, imagine multiplying n minus 1 times n minus 3 over. That's going to cancel these denominators, and what it comes out to is that 10 is equal to a n minus 3 plus b n minus 1. So notice how this statement is true with the reasonings that I gave. We are now able to solve for a and b respectively. If we plug in 3 here, a goes to 0, and if we evaluate 3 over here, we're going to see that 10 is equal to b, 2b, or b2. So notice we plugged in 3 here, a went to 0, we plugged in 3 here, 3 minus 1 is 2, 2 times b is 2b, and then it turns out that b is equal to 5. We do the same with a by plugging in 1. So we're going to plug in 1, b is going to go to 0, 1 minus 3 is negative 2, negative 2a equals 10. That means that a is equal to negative 5. So we now know what a and b are equal to. So we're going to go back up to this factor here and say, well, our overall series is equal to the series from n equals 4 of a, which is negative 5. And let's actually rewrite this as b plus a, because we're going to see that that negative, we want to subtract it. B is going to be 5 over n minus 3. And then we're going to add on a, which is going to be minus 5, negative 5. So we're going to turn the positive into a minus, negative 5, or sorry, yeah, a, negative 5, n minus 1. So our overall series is equal to this. Now I'll let you look at the work quick before I erase it. But basically we have this series now where this is true. Okie dokie, so given that this is the case, we can now do a little bit of what's called the telescopic series. We can use that logic to determine what the sum of our series is equal to. Notice we're starting at an index of 4. Don't make the mistake of just plugging in 1 and saying that's my first term. No, you're asked to start at n equals 4 here. So write out your first 3 terms. N equals 4, n equals 5, n equals 6. Alrighty, to make things more simple, I'm gonna write our series is equal to another series, just written in a different way. So I'm gonna move this up here, because I'm kind of running out of room. 5 over n minus 3 minus 5n minus 1. Okay, so sorry for the cut there. I wanted to check something quick. It got a little strange. So we're going to actually, instead of doing just 4, we're going to plot out 1, 2, 3, 4, 5 parts of the sequence, because it's a little hard to see unless you do that. So let's start. N equals 4. This is going to be 5 over 1 minus 5 over 3. This is the first term. You can look at this as a sequence of terms, but we have to add them together. So it's going to be this part of the sequence plus this part of the sequence plus this part of the sequence, on and on and on until infinity. Hopefully that idea makes sense. So we have our first term. We're going to add it to our next one. So n equals 5. What is that? This is going to be 5 over 5 minus 3, which is 2. This is going to be subtracted by 5 over 4, added to our sixth term, 5 over 3 minus 5 over 5, our seventh term. Now you're going to notice something happens when we go really far down that if you just use 3 terms, you wouldn't be able to see. N equals 7. What happens there? 7 minus 3, that's 4. 5 over 4 minus 5 over 6. There should be a plus there and a plus here. 8 minus 3, 5 over 5 minus 5 over 7. So I want you to notice something that's happening here. We have these terms, they cancel. We have, because it's a negative plus a negative plus a positive, that cancels out. 5 over 2, does that cancel out? Well, I don't see anything that cancels that out, so no. We have 5 over 4, that's going to cancel. 5 over 5, that's going to cancel. And you can imagine that the 6 and the 7 will cancel. Granted, it follows this pattern. So this cancels. We're left with 5 over 1 plus 5 over 2 for our first sequence. And it's going to continue to cancel out until we get to infinity to our last term. So let's keep this here, that it's equal to 5 over 1 plus 5 over 2 plus ... because we need to determine the rest of the sequence. So let's change our variables here. Instead of evaluating at the beginning of our series, let's go to the very end. Let's say, and let's rewrite this here, because we can't just say, okay, plug in infinity. Let's say this is the series as where n is infinity, and let's say k is equal to 4. All right, we were able to do the first step because we're not plugging in infinity. Here we're going to say that infinity is equal to n. So k equals n minus 1. So 1 before infinity. K equals n minus 2. And then we'll do k equals n minus 3. Okay? You're going to expect that two terms should cancel. At least that's what I'm expecting. Let's see if that's really true. So k equals n. And imagine these values are k, I should say. So these are k. All right, so k equals n. 5 over n minus 3 minus 5 n minus 1. All right, this is going to be added to k equals n minus 1. So let's think about this. We're going to say this is 5 over k equals n minus 1. So n minus 1 minus 3, that's 4. This is going to be subtracted by, same diff here, 5 over n minus 1, so this is minus 2. Okay? This is going to be added to we're going to do this again, n minus 2 minus 3, that's negative 5, minus 5 over n minus 2 minus 1, that's minus 3, plus k equals n minus 3. Let's see here, 5 over n minus 3 minus 6 minus 5 over n minus 4. Okay, I'm going to go one more out just to be safe so I don't cancel anything stupid. And I have to redo this entire episode. This one has been long. The telescopic series gets quite lengthy when you do the work. So let's do 5 over, let's see, n minus 1, or minus 4 minus 1, that's going to be minus 5, minus 5 over, let's see, n minus 4 minus 1. Or sorry, this should be minus 4 minus 3 minus 7. Okay, so let's see what cancels. My 1 doesn't cancel. My 3 cancels. Let's see. 2's doesn't cancel. 1 doesn't cancel. My 4 sure does. My 5 will. My 7 and my 6 will definitely. So again, we expected 2 terms. We got 2 terms. So this is going to be minus 5 over n minus 1. And then we're going to subtract it by 5 over n minus 2. So that took a lot of work to see. Do it as little or as much as you want on the expanding. It's really up to you. I personally like to go out quite a bit though. So for our series, I'm going to just rewrite it here to make it look very nice. Our series of 10 over n squared minus 4n plus 3 can be simplified to, or the sum of all terms is equal to 5 over 1 plus 5 over 2 minus 5 n minus 1 minus 5 n minus 2. So what do you think we have to do to find the actual sum? If it's a divergent series, we're going to notice that it's going to be infinite. All right, the sum of our terms is infinite. But what we do is, okay, n doesn't really stand for a number, it stands for infinity. So let's evaluate the limit as n approaches infinity for these terms. So 5 plus, what's 5 over 2? I should know that, like 2.5. I am stupid. So we'll say plus 5, 15 over 2. We'll subtract that by 5 over n minus 1 minus 5 over n minus 2. So let's evaluate the limit. What happens as n approaches infinity? Well, we're going to get 5 over infinity. What does that simplify to? Well, we know anything over infinity is 0, because if I have one cookie and I say, split that cookie up to 1,000,000 people, are you going to have any cookie left? No, because it's going to be given to every single person. You wouldn't even have atoms, because if you think about it, infinity is bigger than the number of atoms in a cookie. Okay, that's a lot. That's a really, really large number. Therefore, no cookie for anyone, not even a taste, not even an atom of that cookie. You get 0 cookie. Everyone in the entire universe of infinite people get 0 cookie. I don't know what the hell I've been smoking, but anyways, this will cancel out to 0, this will cancel out to 0, leaving us with 15 over 12 as our sum of all the terms in the series. Alrighty, that was a mouthful, but hopefully you found this lesson helpful, and I should say this is convergent because the limit exists and the limit approaches a sum of all the values, because we expressed our sequence of terms in our series as a sum of all the terms. Then we found the limit as n approaches infinity, so we can equate for the infinite terms. Alrighty, and we found that it converges to a sum of 15 over 2, not divergent. Alrighty, I hope you found this lesson helpful. If you did, please drop a like, comment, and subscribe, and I hope that you have a wonderful day.